or sorry, 2 buildings, 3 stories, total 48 units in climate zone 3. I'm going to try to keep the same building for all the tech topics that we talk about. So the content and purpose today we're going to talk about utility bills, gas, electric, and water. Kind of how you obtain that information, what you need to do with the information, how to read the information that you plug in EnergyPro and that kind of stuff. And then we have the fan energy, being able to calculate your brake horsepower and give you kind of a little rough understanding of the low-rise fan energy compared to high-rise fan energy and what the energy model looks at when you plug those things in. Okay, so what is the purpose? Utility bills. So utility bills, you want to review 12 months of prior utility bills before you go out on the site. If possible, you can get this information. It's very, very handy. Even before you get out there, you can review them. You can see where they're, you can kind of start trending them just by looking at the utility information and say, when they're using a lot of energy, when they're not. Maybe they are using a lot of energy at a time that you wouldn't anticipate them to be using a lot of energy. So these are good things for you to get in your head, as you go out there to the site and kind of prepare yourself, so you know what you're going to be looking for, or maybe things that you want to look for because of some I guess not so normal utility bill information you were able to get. You can also then take that utility bill information and you can calibrate your energy model based on the actual utility bills. Once you come back from your site visit, collect all your data, and you start building out your framework of your building. So you can model recommendations with more insight on a simple payback for knowing how much energy they use, what they can do to change, to upgrade, and then using that cost analysis to get a simple payback through utility bills. So it's really helping to inform the property owner on where the return on investment will come from, and you can kind of prioritize or help prioritize their options and what they want to get. So utility bill analysis assessment should include utility bill analysis. Analyzing must include base load evaluation, seasonal evaluation, and recommendations for energy use reduction. So again, kind of what I was saying that before, you can, based on when they're using the energy, what part of the season, you can start figuring that out and helping them on recommendations for reducing energy. So you want to request a minimum of 1 year of utility data. 2 more years, or the more data you have, the more accurate you can get. But 1 year, so you can see all 4 seasons, of energy use is ideal, is needed as a minimum. And within your summary reports for the program, you're to include the baseline loads and recommendations in there. I'm not going to go into complete detail of what the report should look like or your summary report should look like, so please refer to the Multifamily Retrofit Energy Modeling Guidelines for those details in reporting. So then we have a couple of different ways that properties are going to be billed. So you may have a master meter, which is 1 meter for each utility type, gas, electric, and water. And so that means just 1 gas meter, 1 electric meter, 1 water meter that's on the site, and it's calculating how much usage you have for each of those end uses. Now it's going to be a lot harder to separate out what your residential usage type is, because if you have common area, corridors, site lighting, those kind of things, if there's a pool on the property and it has pool pumps and things like that, to separate out just the residential usage and the common area usage, it may be a little bit more difficult. You'd have to really kind of dive in and probably ask more questions to the owners and maintenance team to really figure that out. It's possible, and it'd be harder to do. And then I'll show you kind of have examples of utility bills I can show you guys in here in a minute. But the other way is that you can have individual meters for your electric, gas, and sometimes now you even see out there individual water meters for tenants. So especially as the demand, or I should say the lack of water that is coming, the state crisis of water needs, and you're probably going to see a lot more of the water meters installed in property as they charge for water, or the price for water is going to most likely increase. So that's, if you have, in this case, we have 48 units, so the individual meters would be 48 gas, 48 electric, and, if they had 48 individual water meters as well, so every unit gets their own one. Now that one's definitely a lot easier to analyze when you're, if it's just residential you're looking at, because in the program we're just looking at the residents, right? So that's the information we really want to get to. So you'll be very happy if your property owner comes back and says, yeah, we have all individual meters and here's the information. It's going to be a lot more to put together, but you're going to be a lot more accurate in what you're trying to get out of the utility analysis. The second or the third way is just a combination. A lot of the times we see out there is one master gas meter, and say the building owner pays for the gas, and then you have individual electric meters, which then the tenants pay for their electric use. Maybe one master meter. A lot of times I'm seeing out there, and there's also rebates out there for if there is only one master meter, you can recommend having another meter for just the irrigation, and then another meter for in-use or in-house needs. And a lot of times you get really good savings for property owners. This is just a side note, savings for property owners, because their sewer charges are based on how much water comes into the property. So if your 1 meter is both landscape and in building use, well, if you're using say a quarter of that water for landscape irrigation, well, they're getting charged for that through your sewer demand. And so a good savings, and for an property owner, a recommendation would be to have a separate water meter for your landscape, and then you can see that in your sewer charges. They'll see the benefit of that. I know that the utility programs, there's utilities around the state that are incentivizing property owners to do that kind of stuff. So just food for thought. Let me see if I can show you these master meters and individual meter bills. It'll probably be easier. So I've taken some PG&E bills here. So this is a master meter multifamily service. It gives you a meter number, gives you what your rate schedule is, and then it gives you your tier usage breakdown. So if your tier 1 usage, you use up to 24,607 kilowatt hours, you're at this rate, and if you use over that another 7,328, you're within this rate. And so your usage changes, or your cost change based on how much you're using. And so a lot of times, if you ever go into EnergyPro and look at utility rate structures in EnergyPro, a lot of times they'll tell you to double check the tier usages and make sure that they're matching if you're trying to use a utility rate structure. Another quick helpful rule of thumb thing here is that you get your rate schedule up at the top. Then if you go into EnergyPro and you go into your utility, you may be able to pull in that rate structure through here. So if you're ever wondering which rate structure you should use, being able to get a utility bill, it's going to tell you exactly which rate structure you want to plug in there. So this is a master meter, and basically, you know, you have your meter for gas and electric, and they gave me their months. You know, you get your month of usage and billing days and all that kind of good stuff. So a lot of good information in here. And then individual meters, PG&E, you know, you got your rate schedule again, which is very handy to have, and your meter number. And these meter numbers I'm going to talk to you about a little bit more when I show you kind of how to document and graph all this stuff out. But having your meter numbers and being able to track those things back to end uses is going to be important when you're doing your utility analysis. Okay. So those are the different ways you see it. Now, modeling calibration in the program guidelines, they want to try to get it within 10% of the actual annual utility use and 20% of the monthly utility use. So, you know, there is an understanding that there's going to be some, you know, leeway or tolerance within, you know, when you're collecting these things. Energy cost savings calculated outside of the modeling software should be used. You should use the actual utility energy bills or an average utility rate for those things. So this is like your water savings and other things. If you can't model it within EnergyPro, you want to use outside hand calcs. That's great. Process loads and, you know, things of that nature. If you're trying to really calibrate or you know, commission your energy model. While calibrating models is good general practice, please refer to the program handbook for utility analysis guidelines. You know, if you can't get 12 months of data, it's not a requirement to do the utility analysis. We are going to advocate for it because you're really helping the building owners make solid decisions with, you know, a framework that they can understand, which is, you know, money, and they pay for this stuff, so they want to kind of see where that return on investment is going and how it's going to pay back. So refer to the program handbook for the guidelines on utility analysis. We're just going to be talking a little bit about it. So as I mentioned, you request your 12 months of data. That's great. You get it. You know, your property owner, property management, was able to send you that information. You're then going to review all that information, and you need to track it somehow. You need to benchmark it somehow. So I have a sample spreadsheet that we use internally here, and you can, you know, again, you're going to be making your own. You know, you can. What we want to do is just be able to track it back to what the end use is now. So kilowatt hours in January, if we got individual meters, we need to sum all that up. So that's why when I mentioned about the meter number here, you're going to basically need to, you know, correspond a meter number and the month usage and add that all up for the whole year. So if you have, basically what I'm getting at is if you have a large property, 100 units, and they're all individually metered, and you're going to be doing this kind of utility analysis and analyzing, then you know, you're going to want to be able to track, you know, how many times does that meter number pop up, and what is that energy use, and how much does it charge, and all that. You're going to need to track that information. So you can track it in your spreadsheet. You know, we have some added things in here that we look at, but you know, kilowatts and cost and therms and cost is really the big guy that you're going to want. And then if you do water, it's going to be the 100 cubic feet of water and then the cost for that. So that's the HCF, that's the water part down there. And then, you might have some graphs in here. So, calibration, you might somewhere for your summary report, you can make a nice graph and says, this is what our billing was, and then after your calibration, we're able to calibrate our energy model to be the same. Graphs of just what the annual energy is based on utility data, current and monthly costs, that kind of stuff. So you can make it how you want it to be presented, how you want to present the information you gathered. But you definitely need to get this monthly stuff down as we head into EnergyPro. You want to gather all that information and be able to quantify it and then plug it into EnergyPro. So make sure you build something for yourself to track that information. So for people that are not familiar how to get to the calibration section on EnergyPro, basically open your project BLD file, and then at the bottom left corner you click on the calculations, and then click on calibration tab within that calculations window. So I'll show you that now. I'll show you that now within EnergyPro. So.
Kyle, before you get there, let me just answer a couple questions that have come in on the chat, if you don't mind.
Okay, not a problem.
So one question was, when is utility bill calibration required, if ever? And you touched on this in your slide. Just want to be clear. The program does not require utility bill calibration, but we do strongly encourage it. And if you have a project where you would like to do utility bill calibration and you need help with securing the bills, we're happy to leverage our help and support where we can. So we encourage you to do utility bill calibration on every project, but it's not required if you can't get the data. There's a follow-up to that, or kind of a subsequent question to that. If you don't have unit data, does the program have a recommendation in unit load assumption that should be used when modeling? So this is a question about if we don't have the actual utility bill data, is there something else that we can calibrate the model to? And unfortunately, no, we are using the built-in assumptions and framework of EnergyPro to model these buildings. We know that it is not accurate in all circumstances, so that's why we heavily encourage you to do utility bill calibration, which Kyle is going to get into now. So thanks for that, Kyle.
Mm-hmm. Okay, so let me switch over to EnergyPro. So I said you go and open up your BLD file, hit on the calculations. If you're going to res performance, and there's this calibration tab here. So here is basically from the Excel file, you're able to gather all your electric usage. So you're now plugging that information from kilowatt hours and therms, both your usage and your cost. So you're plugging that into here, and then you're going to have that for your gas as well. And then over here, you got to just change this to gas consumption. And then you can have your electric cost and gas costs. So basically that's where you input it, and then I'll talk a bit about how you can kind of read this information right now. So let me get back to my slides. So here's the calibration tab for gas. So I plugged it in, and we got your billing usage, which is what this is looking at, right? Consumption in therms. And you look over, in the May to October months, and we're pretty spot on with what the calculated is compared to what their billing is, right? And so you have to kind of think to yourself, well, that's good, but why is it, right? So base loads in summer months, you're not using your heating, right? It's cooling time, and so your appliances or all your base load therm usage is what I'm kind of saying here is consistent with your billing. And then when you get into the heating gas usage times a month, obviously there's a lot that plays into why that might be different than your billing. Um, you know, in this particular instance, it looks like not many people use their gas in the winter, right? But for our model, EnergyPro robot family, they they work on a lot tighter parameters, right? They wake up at the same time, they get cold all at the same time, so they need to heat themselves up all at the same time, and so there's a lot of different variables. Is kind of what I'm getting at with the way this is, but it's a good way to see if if at least you're trending maybe in the right way or if you're spot on. So again, here's just me saying, ask yourself, why is this happening? And there's many reasons why that could be happening, but it might be, as you're looking at this now, if they're not using a lot, then that's good. So we'd be happy with them. If this was the other way around, then we'd be kind of worried, right? You're using a lot more gas than what it seems to be needed. Okay, so here's our electric profile. Now this is I look at this and I say, okay, well they're trending about the same. This is our calculator. This is what our build is. Now what's going on inside the model that is making our billing a lot higher than our calculated? So that's where this is showing, something in the field is bringing this billing consumption higher. This is where some of the things such as fans are not being modeled accurately within the software. So there's certain things in the building, and I'm going to talk about fans because we're talking fan energy here in a minute, that aren't in the energy profile when you run it. Now, what EnergyPro says, and I'll talk about it a little bit later again, but EnergyPro says basically if a fan is not used during normal operating conditions of the building, then you don't put any information in on it. It's only the fans that they want to see that are running so the building can function. So if there was, makeup fans or supply fans and exhaust fans running continuous for corridor or stairwell ventilation or something of that nature, those things they want to account for, but for bathroom exhaust fans that are on switches that aren't on timers, then they don't want you modeling those. Or there could be a scheduling thing. So in EnergyPro there's schedules that there's on times and run times and percent on and percent off schedules for all the end uses that you have in there, whether it be lighting, HVAC, process loads, occupants, all that stuff has a set schedule. That's the robot family schedule that it runs on. And obviously we don't live in a robot society, so billing, may be higher or lower. This is just a way for us to see how our model is performing and how the building is actually functioning. So I like what I see here. I see that it's trending in the right way. What I can notice is that our base loads are different. Something's going on. It's basically the end result of this is there's something going on during months of heating, so your cooling is off, right? And that's why your winter is basically the direct opposite of heating. Your winter months, you're not cooling, you're not using as much electric energy for this particular building, and thus your base graphs are off, but they're trending in the right way, so that's good. So low-rise residential mechanical ventilation. The standard, we're going to talk a little bit about fans and how fans can affect these these guys, or this calibration. Your standard watts per CFM is a 0.25 as a baseline, 0.25 watts per CFM, but your actual watts per CFM may vary significantly. So I'm thinking of these older properties that we see out there, built in the 70s and 70s or later, you know, the fans, you know, there could be a lot of things going on where it's, you know, they're just old, outdated. They're running a lot. They're, you know, they're super energy inefficient, meaning that they pull a lot more watts but deliver less CFM. So, you know, the way you can, you can calibrate those things, or you can verify those things out in the field, and fan watt draw kind of situation. You could use your flow hoods and whatnot, and you can really get in there and figure out what that energy consumption is. That would be, you know, definitely like above and beyond of what's going on in this recalibration here. But you need to just know that there's things that the building is operating and running this equipment that's not efficient, and that's why you're seeing that billing trend higher than the actual usage in our energy model. So when you're calibrating an energy model, okay, so sorry guys. When you're calibrating an energy model, what I've done here is, so if you notice, the first one was the billing was a lot higher and the usage was lower. So what I've done is, just to kind of show you a visual, is I've added some, I changed that 0.25 watts per CFM. I've changed it. I went higher, and I said, you know, I'm thinking that these things are going to pull a lot more wattage and not give as much CFM. So here's just another graph of that. So I changed that watts per CFM, and then it just from that one change overall, you were able to see that now they're trending and way more accurate. You know, your calculated and billing is trending just almost the same there. So that was pretty. It was a kind of a quick thing that I did just to show you guys how, you know, added energy you add into the energy model to calibrate that energy model to what is actually being billed. You know, there is ways to do it. You want to quantify that somehow. If you want to say that you were out in the field and you know, they have, you know, makeup air fans or constantly running exhaust fans that aren't being reflected into this energy model, but they're there, they're happening. It's using energy, and so that's kind of how you calibrate your model to bill to match the bills. And when you're doing that, then things, as you show recommendations, are going to have more of a direct impact to than what that savings looks like on your econs. I guess it's a really beneficial visual to show to the client, in my opinion, to how you're calibrating your model and you're showing accurately what it is. Yeah, so getting into water savings with utility bills. So first of all, you know, if you're going to do water savings, you're going to need to share or at least have it approved with the Multifamily Upgrade team. So you can email multifamilyupgrade@trscsolutions.com, and if you make your own water savings calculator, they're going to need to approve it. They can put it in there. So the reason why we want to do it is that, you know, one thing is low flow fixtures, and when you're putting in low flow fixtures, that means you're going to be using less water, right? So if it's for heating for a faucet or a shower or something where you need hot water that's serving it, dishwasher, things like that, you want to show the water savings in therm usage reduction, right? And it's, I guess I could try to I'm trying to explain it, but it's kind of hard because you guys aren't here to respond back to me. So if hopefully that makes sense to you guys. But here's a water savings calculator, you know, and you basically trying to calculate your total therm saved for each of your end uses. So here's kitchen, shower, and bathroom, for example. You know, we have some inputs here in the beginning that talk about, you know, how many units you have in there. So we had, you know, 48 shower heads. It's just one bathroom for a 1 and 2 bedroom. So 24 of each bedroom type, and then there's 48 basically of the shower heads and toilets and things like that. So and then you go in and you say, this is what we saw on site: 2 GPM for aerators in the kitchen sink, 1.5 or 2.5. It depends on what building you're in. So maybe some tenants changed out, some didn't. So you need to document what that is and get an average water use. All right, and then as you go in, you're going to say, well, we're going to change out from our average flow rate to a 0.5 flow rate, and you know, the savings we're getting now. And these calculators get a little bit involved, and you know, based on climate zones and things of that nature, you're going to have a different. It's not going to always be the same for, you know, if you go from you know 2.0 shower head down to 1.5, it's not going to be consistently across the board how many therms you're saving. So there is other bits and pieces to the calculator that go into that report or go into that, making that end use summary savings. And you know, that's why when you do build something like this, you are going to need to get it approved by the upgrade program representatives. Okay, but you can use water savings, and it's recommended to use water savings for your recommendations to the owners. Is there any questions right now, Mike, about that? I know I was kind of, you know, trying to explain it, but I don't. If you got any questions, I'd be happy to try to explain some more.
Yes, please. Thanks. Thanks. There's been a couple questions that have come in. So the first one is about the billing periods. Can you talk a little bit about if you receive your utility bill data on an off cycle from perfectly monthly, how you would reorganize that to input into the screen that you have on the up on the webinar right now?
So basically, how would you get to the total for the month?
Right. Just going back to your spreadsheet, the way you organize the data. I mean, if your billing period starts on the 10th and ends on the 9th, you just need to be cognizant of the fact that you need to reorganize that data before you put it into the EnergyPro screen that you were talking about there. Yeah.
Yeah. So you're going to need to. So that's kind of talking about, you know, you have your meters and your billing cycle days and what falls when and where. Yeah, you definitely need to do the upfront organizing of it. So you might have, you know, a column for all your meter bills that end in, you know, 933 or whatever the nomenclature is for that bill. And then you want to just, you know, make sure that, you know, at the end of, you know, November 15th, we get one that has, you know, the next billing cycle is going to be November 16th to, you know, December whatever, 25th or whatever it may be. But I mean, I would just consider that, whatever the month is that you're really in there. I know it's kind of hard for this one because it's right in the middle, but you're just going to want to move it and adjust it to what it would be. You don't want to pile up, 2 bills in 1 month. So whatever that rearranging may take to do, then you just have to do that. Unfortunately, each of these bills, the way that this PDF is showing it is this month period for every single meter. So if you notice, these meters are changing names here, which means it's a different residence. So I don't have one PDF that just shows 1 meter throughout the year.
That's fine. Just a reminder to everybody that you got to organize your data before you can really use it.
Yeah, and that's where this comes from. That's where this whole spreadsheet. That's what I was explaining to people to make sure that they make their own way of doing that.
So the next question is, if we have apartment addresses, will PG&E provide utility bill information, or must we secure hard copy information from tenants? Can we provide tenants a release form PG&E will accept so that we can get utility bill information from PG&E?
Yeah, so you're going to need the sign off from the tenant or owner. So you can't just give an address and say what's this person paying electricity. PG&E, or they're most likely not going to give you that information. So I've done in the past, you get release forms, or you have the property manager or owner kind of look to get that information for you. So you may not be able to get everybody. Some people might be sticklers and not want to share that information. So you want to get a good pool of information, I would say. Obviously, if it's a 100-unit building and you only got 5 utility bills for each one, it's probably not a very accurate representation of the whole building. So yeah, you got to kind of figure that into the equation.
Yeah, and as I said before, we at TRC are happy to help you secure this information. We just finished working on a project, or the project is not finished, but we helped a project secure the tenant release data for 104 tenant spaces, tenant meters. Both gas and electricity, interestingly enough, were individually metered at this property, and the property wanted the data for multifamily upgrade, but also for other programs that they're applying to. They're doing a pretty deep retrofit, so they really wanted to get the bills. So it is possible. It is very difficult, but in that case, we had to secure 104 individual tenant signed copies to access the data. So if you need help with that, or if you need the forms or anything like that, please feel free to call or email us at TRC, and we can put you in touch with the right people. A couple more questions here, Kyle. Should we model garage exhaust fans? This is, from a program perspective, we are concerned with residential energy use. In general, if the garage fan is not part of your scope of work, I would say exclude it from the model. If the garage is part of the building, and this is more likely the case in a high-rise project, we would recommend that you include that garage fan in the model, also because using a high-rise model you have more granularity and control over how that system is modeled and input. But in general, for our program, you can exclude garage exhaust from your models. There is one question that speaks to the calibration section that you were just looking at, Kyle. I'm not sure if you're getting into this later, but can you explain the normalized billing data function on the EnergyPro checkbox there?
Sure. Yeah, I wasn't actually going to touch on that, but I can show you what it does. Basically, normalizing your data is going to give you this other kind of graph that is taking your build and your calculated and basically kind of flatlining it and making it look more normalized. Not exactly like I think that's basically all it does. It's not normalizing any of the internal calculations. It's just simply providing you that normalized, what it would look like for as a normalized. It's just a visual. It's kind of why I wasn't really going to talk too much about it, but it's
Thanks.
basically just
No,
a visual.
Yeah, helpful to just bring it up. And then last question, if there is a central exhaust fan serving the whole building that pulls constant volume from each unit, and in high-rise, should the fan watt draw be divided between the units, or how can this scenario be modeled?
It's a good question. Yeah, so it sounds to me that would be it would almost be as if, so it's a central exhaust fan pulling exhaust from each of the units, and so it's a large fan. You're trying to split up that watt CFM within the tenants. If it's high-rise, you should be able to build that exhaust fan just as it is as one fan and not have to split it up within the tenants. You're still going to get the energy consumption of that fan in your model. So you wouldn't have to go through the exercise of splitting it up and putting in that, 0.3 watts per CFM or whatever it may be for your each space. Now I can show you how I do that. I mean, for the exhaust thing, you go in this low-rise residential mechanical ventilation, and you basically just, if you override this, default values, like I said before, are going to be 0.25 watts per CFM, but you can override this and say, it's 20 watts and it's only pulling 45 CFM, which is about 0.44 CFM, almost double what the base or the standard is, and that's what I used to plug in and get that last graph here. Let me see if I can, that one there that you're seeing. So when it was this, when it was 0.25 watts CFM, and then when I put in 0.44 watts or something like that, 0.45 watts CFM, it brought it up. But that's not to say that, I mean, I put that number in there to show you guys what can be done to manipulate it. Like I said, and I'll say it again, you want to be able to quantify that energy use. So if it might not be a bathroom exhaust fan that's super inefficient, that's bringing this building billing up higher than what the calculated usage is, it might be some other things outside of that you find, and you're able to then do hand calcs on the side to interpolate that into maybe a watts per CFM. You need to be able to explain how you got to that number. You can't just plug in a number and hope that the lines match up. So to answer the question, high-rise exhaust fan, single fan, you're most likely, what I would do is plug it in as exhaust fan under one thing. You're going to calculate the energy use, and I wouldn't get into the individual residents for that.
Thanks. We're all good on questions.
All right. Briefly talked about the fan energy here earlier, but I'll get into more detail now. So residential fan systems shall operate continuously during scheduled operation hours except for residential units or high-rise buildings. So basically what that's saying in EnergyPro is that if it's not used under operation hours, then don't put it in. If the fan for heating and cooling is, so your fan for your furnace or your AC is intermittent, you want to select it for that, and then at the end it's going to turn on intermittently as your need for heating and cooling is on. So if you ever get into looking at CSV files and stuff like that, and mess around with the continuous and intermittent fan energy, it should be exactly what it's doing. If you haven't set it intermittent, then the fan is going to turn on for if it's in cooling, or a fan's going to turn on for heating, and that's at its operating hours, so that's good. But anything that's on a switch or something like that, it's not supposed to be in the model. This is continue. This is just kind of straight from EnergyPro. Modeling software shall include all HVAC fans in the systems that are required to operate design conditions. And then again, exhaust fans are manually controlled, such as bathroom fans, may not operate in design conditions and therefore shall not be included in the fan system power demand calcs. Now, you can put them in as side calcs. You can figure out what that is on the side, but it's going to be hard to quantify it. So when you do put in fans, you want them to be, you want to put in the energy at an operating condition. So you read a nameplate of a fan and you see that it's 5 horsepower or something, and that's basically what it's rated as. So at the it can move up to 5 horsepower, but not much further, and most of the time it's not going to be operating at 5 horsepower all the time. So knowing and understanding the elements that go into basic horsepower calcs is important. You should become aware of these because it's going to be increasing the awareness, your awareness, and your client's awareness of energy consumption. So I suggest kind of looking some stuff up and reading about it. I'll talk about it here a little bit, but definitely do some research if you're not sure what brake horsepower is or horsepowers are, or how many watts is in a horsepower. You should kind of know those fundamental things when getting into it. So here's just a nameplate example, and I will be going back and forth from this. So you have here's our horsepower. So I'm showing obviously a large fan so I can really show you guys how the brake horsepower changes. But so this is 350 horsepower fan, and you have your volts and amps. And volts and amps equals watts, right? So that's something you want to know. You have a safety factor. So this is 15% over there's a safety factor of 15% over 350 horsepower. So basically it's not going to blow up at 300 when it hits 350 horsepower, but it's getting pretty darn close. So there's safety factor, performance factor, and then your nameplate nominal efficiency of the fan. So these are all very important when we get into, we're going to need all these things when we talk about calculating brake horsepower. So you can get all this information. If it's not on a nameplate, you can get all this information, manufacturer's data and product data and stuff like that. So voltage, listed on the nameplate, the motor may operate at any voltage within 10% of what is listed there. Full load amperage, basically this is how many amps the current of the motor will draw when it's at its rated horsepower, so full load amps. Percent efficiency, efficiency is listed in most motors, but not all. Motors that fail to state their efficiency probably have poor efficiencies and don't want to show it. So if it's not listed, it can be determined through basic math, and you can look those things up. You may be also to look up what is the efficiency of a motor, it's a belt drive, direct drive, ECM, those things have kind of standard efficiencies that you would be able to pull from. So power factor. So common power factor ranges from 0.7 to 0.98. The higher the power factor is, the more desirable. So the power factor tells you what extent the motor voltage and current when are out of phase from one another. And then the power factor brings those voltage and current back in phase and how good they can do that. So basically, this is the last bulletin says, when the voltage and current are not in phase, Ohm's law will not work. So unless there is a power factor used to correct the phase difference. So yeah, there's always going to be a power factor when you're dealing with voltage and amps and ohms and all that jazz. So you're just going to need to figure out what that is. And again, it should be on the nameplate. If not, manufacturers will be able to give it to you. So here's just a single phase brake horsepower calc. And you can look these up. You can get, if it's 3-phase, 2-phase, you can find how to calculate them separately. I figured single phase is the easiest way. So again, we have volts, amps, percent efficiency, and power factor. And then 746 is your number to not forget. That's 746 watts and 1 horsepower. And so the way that the math worked out for that nameplate I showed you earlier, we saw the rated horsepower was 350, but your actual brake horsepower, which is your operating condition power horsepower, is 201. So quite a big difference there. Obviously when you're dealing with larger fans, you're going to see that. And then if this is a pretty efficient fan in itself too. So you begin to less efficiency or lower performance factors and stuff like that, or power factors, then things obviously will change. But yeah, I mean, if you do have those high-rise buildings with those central garage exhausts that are on a VFD, I mean, or if you have it on carbon monoxide sensors, where it's going to power on, it's going to operate for, certain parts per million, and it's going to operate for 20 minutes till that's diluted at what range. I mean, these are all really fun hand calcs you get to do on the side if you're really going to get into the weeds of calibrating it and figuring that energy consumption out. And RPMs and CFM and all that kind of stuff. You really get to find some fun things out about fans. It's a lot of information to talk about, and so I'm not going to get into too much detail of it, but it's definitely essential to understand how fans work and how to calculate a brake horsepower, because you are going to want to put that in your energy model as brake horsepower. And if you have it in as horsepower and you're seeing that your actual is super high, that definitely go back and check your fan energy and look to make sure you got it in as brake horsepower and its operating conditions. Are there any questions?
Sure, a couple questions. Just a couple clarifications on your nameplate. The term SF stands for service factor. Is that correct?
Service factor or safety factor, I can't quite remember. I thought it was a safety factor because it's a 15% safety factor on top of it, but it could be service factor. It's basically the same thing.
Yep, basically the same concept, but slightly different naming convention maybe. And along those same lines, PF I think is the power factor.
Yeah.
And those two numbers are used as you're looking at the slide, the slide we were just looking at to calculate the brake horsepower.
Yeah.
There's a clarification or comment that in high-rise buildings, only 4-pipe fan coils, water source heat pumps, and PTAC units can be scheduled as intermittent. For all other HVAC systems, the supply fan will run continuously. This was a comment from one of our participants, I believe to clarify the function of the HVAC systems. If it's a question about how the program would ask you to model these scenarios, please refer to the modeling guidelines or ask me offline if you have a specific question. But in general, the comment sounds correct to me. Kyle, do you have any comments about only the 4-pipe fan coil, water source heat pump, or PTAC systems should be scheduled as intermittent?
Yeah, no, that sounds accurate to me as well. And I know that for those high-rise buildings, your baselines are obviously different. So you're going to be looking at that 4-pipe fan coil as our baseline. So yeah, no, that sounds right.
And another question. If you calculate the brake horsepower for your fan energy under design power, what do you enter into EnergyPro as the drive efficiency?
Oh, so you're basically wondering if the drive efficiency takes into consideration your fan horsepower?
Right.
You're still going to be putting in what your whatever your drive efficiency is, but you're going to still need to calculate what that brake horsepower is of the fan. So to answer your question, the software does not take your horsepower number and then say what your drive efficiency is, a percentage of that, and calculate that fan energy out. You have to plug in the brake horsepower.
Okay, thanks. And this is a question for the program. Has there been a project submitted that uses EnergyPro 6 with the Energy Plus engine under the 2013 standards? So this is a retrofit program. This is for multifamily retrofit projects. The multifamily new construction program is called the California Multifamily New Homes Program, which is also run by PG&E. And I cannot speak to whether or not they've received a project and submitted a project under the EnergyPro 6 using the Energy Plus engine yet. But regardless, that's another discussion. I think that we've answered all of the questions. I'll leave it up for just another minute here. If there's anybody else that has a question or clarification, please speak now. And I just want to take this time while we're waiting for any additional questions to remind you that there will be an assessment review training that's happening next week on Wednesday. You will receive an invite to that. If you are a qualified partner in our program, you should be receiving that invite today or tomorrow. I'd also like to remind you now, when we close this webinar, you will be prompted with a survey. And in that survey, we're going to be asking for some feedback as well as your BPI registration number, and we will collect those registration numbers and assign credit for your attendance today at the webinar. And thank you for your attendance. One last question before we wrap up. Is this presentation going to be available for later? Yes, all of the presentations that we're giving by webinar in the Multifamily Upgrade Program are available on the Multifamily Upgrade Program YouTube page. If you need information about that, you can ask us, or you can find a link to that page from our website, which is multifamilyupgrade.com, or the partner portal if you have access to the partner portal. I think that that's all the questions, so I just want to say thank you very much, Kyle, and I'll leave you with the last word.
Okay. Well, thanks, everybody. I appreciate the questions and feedback. Again, we got another one of these scheduled in 2 weeks on VRF systems. So I hope to see you all then.